All right, Chapter 7, Problem 10. How fast must a 300 kilo elephant move to have the same kinetic energy of a 65 kilogram sprinter running at 10 meters per second? So, what is the kinetic energy of the sprinter? All right, it is 1/2 of the mass, all right, 1/2 times the velocity squared. So in this case, 1/2 of 65 kilograms times 10 meters per second squared. All right, 1/2 mv squared. So the kinetic energy of the sprinter is 0.5 times 65 times 10 squared, right? 3250 joules. 3250 joules. Now you can see from the units that would be a kilogram meter squared per second squared. That's a joule. So now we need the kinetic energy of the elephant to be equal to the kinetic energy of the sprinter, right? So 1/2 of the mass of the elephant times the velocity of the elephant with an E, today we'll do elephant with an E, squared, right, has to be equal to 3,250 joules. So the mass of the elephant is 3,000 kilograms. All right, so the velocity the elephant needs to go at, squared, is 2 times 3,250 joules divided by 3,000 kilograms equals, okay, equals 2 times the 3,250 divided by 3,000. That's velocity squared, and we're going to need the square root, so let's go ahead and take it, right? So 1.47, so 2.17, 1.47, 2.17 meter squared, second squared, and the velocity of the elephant is 1.47 meters per second. So the elephant needs to be just going 1.47 meters per second to have the same kinetic energy as the sprinter. And that was part A. Now, part B. Okay, discuss how the larger energies needed for the movement of larger animals would relate to metabolic rates. Well, here you are, a 65 kilogram sprinter going along at 10 meters per second, and all you got to do is put in an energy at 3,250 joules to get there, all right? And then if you're a large animal to get there, you to that energy, right, you only get up to 1.47. And so the metabolic rate for the larger elephant, yes, for the elephant, it would be, we're putting out, let's see, we're putting out more energy per kilogram, right, than the elephant, right? We're putting out, to go the same speed, we're doing a lot more energy per kilogram than the elephant. So let's look at that, right? Energy per kilogram. So for us, us being human, right? For human, we've got we've got 3,250 joules per 65 kilograms that we're burning, right? 3,250 divided by 65. 3,250 divided by 65. So we're having to burn 50 joules per kilo. All right, joules per kilogram. The elephant, on the other hand, is also at 3,250 joules, but 3,000 kilograms, right? So 3,250 joules divided by 3,000 is 1.08 joules per kilogram, right? So the elephant only needs to generate 1.08 joules per kilogram the sprinter has to generate 50 joules per kilogram, so the metabolism of the elephant is probably lower than ours. All right, that's it for problem 10.